Hello everyone. I am Professor Amit Vyas, Computer IT Department from Dr. Subhash Technical Campus. Today we are discuss about the subject of mobile computing and wireless communication. So we can start antenna and propagation mode. First of all, we can show what is the introduction of antenna. Two persons who need to convey a thought, an idea, or any doubts can be by voice or any communication. Here, the communication take a place through the sound wave. However, if the two persons want to communicate who is a longer distance, then we have to convert the sound wave into the electronic wave. So this is the one image of how can you communicate to each other based on the distance. If the distance is very small, then easy to hear and easy to communicate. So if the data we can send or communicate to each other, that time the sound wave we can convert it into the electromagnetic wave, and the waves we can transfer to each other. So we can start the next. The device which convert the required the information signal into the electronic wave, it is known as an antenna. So what is the antenna? This is one antenna. You can show that. So what is the use of antenna? The convert is required the information signal into the electronics wave. It means the information signal is convert into the electronics wave. It is called the antenna. An antenna is a transducer which is convert electrical power into electromagnetic wave and also vice versa. It means antenna is converted the electronic power into the electromagnetic wave, and also we can convert electromagnetic wave into the electrical power. So this is the use of the transducer. Antenna can be used either transmitting antenna or receiving antenna. So antenna mostly used either transmission medium as well as receiving medium. So antenna is a most helpful for the communication to each other based on the signal, and signal we can convert the electromagnetic waveform. So this is the basic introduction of the antenna. Now transmitting the antenna is one which is convert the electrical signal into the electromagnetic wave and radiation of them. So also we can signal is transmitted into radio wave. A receiving antenna is one which is converted the electromagnetic wave into receive beam into the electrical signal. So what is the transmitter and what is the receiver? So the transmitter is electrical signal is converted into electromagnetic wave, and receiver is a electromagnetic wave is converted into electrical signal. So first of all, signal is transmitted into electrical wave, and then receiver is used the signal of the electromagnetic wave, and it is converted into electrical signal. So the two-way communication, the same antenna can be used for the both the transmission and receiving. So the antenna is used for the transmission as well as receiving information. So this is the basic introduction. What is the antenna? Antenna mostly used as a transmitter as well as receiver because of the only signal we can transfer and receiver both in the antenna form. So now we can show the next topic of propagation mode. Here we can show the three types of propagation mode: ground wave, sky wave and line of sight. So we can start the introduction of the propagation mode. So in propagation mode, in the Earth environment, electromagnetic wave propagate in the way that depends on the property, but also on those environment itself. The various method of propagation mode is dependent on the frequency. A signal radius from the antenna travel along on three routes. So we can show the ground wave, sky wave, or line of sight. Now we can start. What is the ground wave? So ground wave is also called the surface wave. So radio wave in the VLF band propagate into the ground. The wave is connected at one end to the surface of the earth and ionosphere at the another. So we can show that this is the earth for the surface, and this is one transmitter antenna, and signal we can transfer the ionosphere. The ionosphere is the region above the stratosphere from the above 15 to 250 miles above the earth. So what is the ionosphere? The ionosphere is a range is 50 to 250 mile above for the earth. It is collection of ions, which are the atom that have some their electrons stupid of the living two or more electrically charged object. The sunrise causes the ion form which is slowly modified. So what is the ionosphere? We can show it is the collection of the ion and a number of atoms which is live into the ionosphere. The signal is transmitted into the earth for the 250 mile for the electronics wave in ground wave. Now the propagation mode of radio wave in the presence of ion is drastically different than the air, which is why the ionosphere play the important role in the most of mode of propagation. So the propagation mode we can show here. So the propagation mode we can show here. The signal is travel through the ionosphere and then after receiving the antenna. So this is the ionosphere. It is the importance role the signal is transmitted. The ground wave is travel between the two limits, the earth and ionosphere, which like a channel. The channel is curved with the earth. The ground wave will be follow. Therefore, the very long range propagation is possible using the ground wave. For example, ground wave is communication AM radio. So what is the use of the ground wave? Ground wave mostly used for the signal transmission in the ionosphere and used for the AM wave, AM radio. So now, next is sky wave. So what is the sky wave? Radio wave is a low frequency and medium frequency range also in propagation mode. So what is the LF? Low frequency and medium frequency, but the sufficient for the loss and particularly high frequency. So the loss is very in the ground wave. So we can use the sky wave. So the sky wave are reflecting from the ionosphere, while the wave is the ionosphere. It is strongly bent and reflected ultimately back into the ground. So what is the ionosphere used in? What is the use of the sky wave in ionosphere? The signal is go to the sky wave directly, and then we can directly reflect it, this signal into the particular wave in the earth. So if the signal is travel from any radio tower to the ionosphere and then after signal is reflected, so the speed also is high and the distance is very long. It possible to the ionosphere. So what is the sky wave? A sky wave is transmitted to the ground wave to the ionosphere and the signal is reflected, but the range is very high compared to the ground wave. From the long distance away, this is the appear from the reflection. Long range is possible in the mode also up to the 100 of mile. So what is the use of the sky wave? The range of the signal is very high and the transmitter with the reflection mode of the signal is very high. So mostly use the sky wave compared to the ground wave. So now next we can show sky wave is a frequently band and usually only possible at night when the concurrence of the ion is not too great, since the ionosphere also tend to the altitude at the signal. However, the night there are just encourage the ion to the reflect the wave but not reduce the power too much. So mostly used in the radio, CB radio, international broadcast such one BBC. So this is the use of ionosphere and also for the sky wave. So this is the use of the sky wave. We can show that reflection from one to another based on the signal, but the signal is transmitted long range. Now next we can show what is the line of sight. So the line of sight propagation mode. Transmitting and receiving antenna must be line of sight. First is satellite communication and second is ground communication. So what is the satellite communication? Signals above 30 megahertz is not reflected by the ionosphere. And what is the ground? Antenna within a effective line of sight due to the reflection. So this is the main difference between satellite communication and ground wave. So we can show that this is the line of sight. The signal is travel directly from one antenna to another antenna. Signal is not travel from the ionosphere but also in the ground wave. So this is the earth's surface and signal is travel from one antenna to another for the transmitter to receiver in the line of signal. It means the no interaction or signal is not go to the ionosphere. We can show the ionosphere here also. This is signal is go to the ionosphere, but in the line of sight signal is not go to the ionosphere. So this is one transmitter and this is one receiver. Signal is travel for the line of sight. So what is the reflection? The microwave by the atmosphere. The signal is travel the atmosphere. Velocity of the electromagnetic wave is the function or density of the medium. Then when the wave is changed, the medium and speed is changed. Wave is bent at the boundary between the medium. So what is the signal reflection? Signal is travel, electromagnetic is travel, density of the medium. It means the signal is traveled if the line of sight wave. If the signal is any change, that time in the boundary or medium is changed, the speed is changed and the problem of the receiver. So this is the reflection mode. Now we can show this is the radio line of sight equation. D equal to 3.57 H and otherwise D equal to 3.57 where what is the D means the distance between antenna and horizontal based on the kilometer and antenna heights and the adjustment factor we have reflected and rule thumb K equal to 4/3. So this is, you can find the radio line of sight signal. So this is the line of sight. You can show the ground wave, sky wave. Now line of sight, some of the details we can show that this is the one factors is affected in the line of sight. So line of sight is a type of propagation that can be transmitted and receiving data only, where the transmit and receiving station are in the view of each there without any sort or obstacles between them. So if no interaction is occupied, you can show that no interaction or any signal is destroyed in the line of sight. FM radio, microwave and satellite transmission are the example of the line of sight communication. We have examined various implementation information carry the capacity of the communication link. Which most impairment factor is affected, we can show that the attenuation of the signal in the distortion. So strength of the signal falls off the distance over the transmission medium. So how can you signal is transmitted from one to another and which factor is affected, we can show the attenuation introduce the three factor of the unguided media. So we can show the guided and unguided media. First factor is receive the signal must have sufficient strength so that circulately in the receiver can be interpreted the signal. So what is the first point? Signal strength is very high that time. Receiver we can easily receive and interpret the signal. Signal must be maintained the level sufficient higher than the noise to be receiver without the error. So if the error in the signal, that time you have not received particular signal because of the noise is very high that time. So what is the free space loss? For any types of wireless communication, the signal is disappear with the distance. Therefore, the antenna with the fixed area will receive the less signal power the further than it is the transmitting antenna. So what is the free space loss? The signal is travel very long distance at that time. The signal is lost any particular time duration or any fixed space. That time the receiving antenna is not receive particular signal. That time signal is lost. You can show that any broadcast of the live, any match or any news, that time signal is lost. Then the receiving antenna is not maintained the signal level. So the next satellite communication. This is the primary mode of the signal is lost. Even if no other source of the attenuation or implement, as I assume that the transmitter signal is attenuate over the distance because the signal is very spread over the large area. So what is the satellite communication? Mostly signal is lost. The antenna we can updated or any signal is not received. That time the problem is occupied. So what is the formula? You can show that how can you calculate the signal is travel the satellite communication, then it is also in the ionosphere. So we can show the equation. This is form of the attenuation is known as a free space loss. What is the loss? You can count that here. The equation is pt upon pr and 4hd square and the lambda square. Then this is the equal to the 1 frequency also. So this is the one signal power transmission antenna. PT and PR is means signal power receiving antenna. Then what is the wavelength and propagation mode? And the C, it means the speed of the light. You can calculate the loss of the signal or any space loss of the signal. Now we can show the most important factor is affected in the signal is a one noise. So noise is a Impact factor, you can transmit the data or any signal from one to another. That time you can affect it. So first is thermal noise. So the thermal noise is due to agitation of the electrons. It is present in the all electronic device and the transmission media and the function of temperature. Thermal noise is uniformly distributed across the frequency spectrum and hence often referred to the white noise. It cannot be eliminated and therefore the place is upper bound on the communication system performance. It is particularly significant satellite communication. So we can calculate n equal to kBt. So what is the thermal noise? Mostly is uniformly disturbed across the frequency spectrum. If the frequency is low, that time you can show the noise is occupy or any problems for the transmitter. That time noise is very high. Then the signals you can problems you have receiving. Then next is intermodulation noise. If the signal with different frequency share the same medium, it means interference caused by the signal produced at the frequency that is sum of the difference of the original frequency. Intermodulation noise is produced when there have some non-linearity in the transmitter receiver or any interleaving transmitter system. So what is the intermodulation noise? We can show that here also. The signal is produced the frequency and in some or some different original frequency. It means the frequency you have changed from transmitter or receiver. That time you have occupy intermodulation noise or any other linear or non-linear frequency is produced on transmitter and receiver. That time you can found intermodulation noise. So this is one noise. Then last we can show that what is the crosstalk. Crosstalk has been expired by the anyone who while using the telephone has been able to hear another conservation. It is unwanted occupy between signal and path. You can show that in many times you have a telephone cable. That time you can use. You can find out the another signal you have calling or any information from the another home or any town. At that time you can find the crosstalk. It means you can find you have call for any person and then call is not receiving at particular person for any number, but his call is receiving for another person or also occupy some noise or exchange the telephonic information from one to another. It can be occupy the electrical coupling between nearby the twisted pair or coaxial cable or any multiple signal. So signal is transmitted from one to another. That time you can problems you can occupy crosstalk. Crosstalk can also be occupied when unwanted signal are picked up by the microwave or all through the high directional antenna used by the microwave energy. Does the span during the propagation mode. Typically, crosstalk on the same order of the magnitude or less than thermal noise. Unlicensed ISM band and crosstalk offer the denominate. Impactful noise. It is the non-continuous and consistent irregular pulse or noise spark for the short duration or high amplitude. So what is the impulse noise? The non-continuous and inconsistent and irregular noise is occupied for the any transmitter and receiver for the any direction, but the amplitude is very high, so it is called the impulse noise. It is generally from variety of cause including some external electromagnetic wave for the disturbance such as some lighting or any fault. We can show the communication system is faulted. Im- uh, Impulse noise is generally only minor, any ones can be analog data. So this is the crosstalk and impulse noise. You can show that. So we can show what is the antenna. We can show that the signal is information from one to another, but the transmitter and receiver also in antenna. So what is the antenna? Information signal into the electromagnetic wave. It is known as an antenna, and the convert the electrical power into the and and what is the antenna? Antenna is a transducer which is converted the electrical power into the electromagnetic wave, and also antenna is a transfer or electromagnetic wave into the electrical power. So what is the antenna? It is a transmitter as well as receiver. Signal is you can transmit it and is convert into waveform, and also receiver is receive that time his signal is received in the information form. So this is the antenna. And what is the propagation mode? We can show the ground wave, sky wave, and line of sight. In a ground wave, we can show that the signal is travel in the ionosphere, and ionosphere signal is go to the another receiver. So one is a transmitter and another is receiver, but signal is range is 50 to 250 mile up above from the earth. We can show that the ground wave. Then next we can show the sky wave. So what is the sky wave? Signal is directly go to the ionosphere in the line wave, and then directly go to the reflect the signal in particular earth in the receiver. So not a same as a ground wave, but the signal is travel directly in the ionosphere, and ionosphere directly reflect to this signal into the earth. This signal range is very high compared to the ground or ground wave. Now line of sight, you can show that signal is travel from line of sight. It means in the line wave. Not any other interaction or not signal is go to the ionosphere, but signal is travel in the line of sight. If the signal is here, the antenna is only line wave. So here antenna is here. That time the signal is medium is changed. That time boundaries you can change. That time the speed is very low, and the problems is occupy in the receiving signal. So this is the line of light wave you can show. Then we can show that what is the attenuation and how can you destroy the signal. Then what is the free space loss? Signal is travel into the satellite communication. That time signal is lost in particular path, then is count you can lose. Then noise you can occupy. Signal is travel in the long distance, that time you can occupy the noise for a uniformly and ununiformly wave. So the intermodulation noise, and you can crosstalk. So we can show the crosstalk and impulse noise is a for the noise section. So we can show the antenna and propagation mode. So thank you all of you.